If 3 plus 3 raised to the power n plus 3 equals to 81, what is the value of 3 raised to the power n plus 2 as a whole like this? So the solution, so when we have exponential equation like this, we can, when you look at this left hand side of the equation, we can factor the base by saying 3 into 1 plus 3 raised to the power n plus 2, okay? Because when you say 3 times 1 is 3, okay? So you have invisible 1 here. When you multiply this with this, you have this. So when I say 3 raised to the power 1 times 3 raised to the power n plus 2, okay? Law of indices, I have 1 plus n plus 2, that is 3 raised to the power n plus 3, this is same as this, okay? So from here now I have this equals to 81, okay? So I can divide both sides by 3, okay? So this can go, so I have here 1 plus 3 raised to the power n plus 2 equals, when I divide this I have 27, okay? So I can transfer this one to the other side. I have 3 raised to the power n plus 2 equals to 27 minus 1, that is 26. So my answer is 3 raised to the power n plus 2 equals to 26. This is a requirement, I should look for it. Okay, we have to solve 3w over 16 minus 1 equals to 1 over 2. Solution. So here we can transfer this to the other side. We have 3w over 16 equals to 1 over 2 plus 1. Okay. So this one is set as saying 1 over 1 over 2, or 3 over 1 over 2, or 3 over 2. So you say 2 times 1 is 2 plus 1 is 3 over 2. So let's replace everything here with 3 over 2. And let's break down this, which is 3w over 16. So you can cross multiply. 2 times 3w equals to 16 times 3. This gives 48. This gives 6w. When you multiply this, divide both sides by 6. This gives us 8. 6 can go. That is w standing on its own. Equals to 6 here 1. 6 and 48 is 8. Y equals to 2s raised to the power p plus q s raised to the power 2. And the y ds is 14s raised to the power 6 plus 6x. Find the value of p and the value of q. This is a requirement. So we say solution. So when we look at this function, we are asked to figure out p and to figure out q from here. But in the question they said the y ds is given as 14x raised to the power 6 plus 6x. So what this means is that there's a function that was differentiated to arrive to this. So to figure out that function, we need to integrate this differential equation to get the original function that was differentiated to get this. So to do that, we integrate by adding 1 to the power and divide the coefficients with what we have. So 6 plus 1 is 7. So we divide this by 7. And when we add 1 to this, we have invisible 1 here. So add 1 to it. 1 plus 1 is 2. Divide this by 2. So the function now gives us 14 divided by 2 is 2x. 6 plus 1 is 7. Plus, when you divide this, 2 here, 1, 2 here is 3. We have 3x. 1 plus 1 is 2. So we have this, the original function that was differentiated to get this. So let's take it back to this. Equals to, we have 2s raised to the power p plus qs squared. Now when you look at this, when you compare this to this, it's like saying 2s raised to the power p plus qs squared. So when we look at it very well, from here, the value of p represents 7, the value of q represents 3. So therefore, our p equals to 7 and our q equals to 3. Thank you.